Hey engineers, and welcome to calculating trusses with a truss calculator. We went through this by hand, and you saw how arduous that was, using sine, cosine, everything pulling down equals everything up, everything left equals everything right. And at the end, I showed you how to use a truss force calculator to do so. So I'm going to take you through this kind of a little bit slower so you have an understanding of how to build a truss in a calculator. So this is a website that I've linked to in Schoology. The first thing we need to do is we're going to work our way across the top up here. So we're going to put our points in. So we're going to put all of our points in first. So we'll put the XY values 0, 0. And then I'm going to try to put them in order. So it goes A, B, C, D. So this is going to be the point 3, 4 for the next one. And you'll see that these points start populating as I put them in. Go to my next one, which is over here, C. That's going to be 10, 0. And then my last one is going to be 3, 0. Point D. So you can see I've got all my points here, A, B, C, D. They don't name them A, B, C, D. They're just going to default name them numbers. The next thing I'm going to do is I'm going to build trusses. So they're going to ask you for the nodes. So my first one is going to go from 1 to 2. So I'm going to hit 1, 2. And then it's going to put a truss in there. And I'm just going to, for my material, I'm just going to say 1. My next one's going to be 2, 3. My next one's going to be 3, 4. And then 4, 1. And then I'm going to go 2, 4. And it doesn't matter what order that you put these in. The next thing, material, it doesn't matter. This stands for the cross-sectional area, and right now we don't really care. And then E stands for Young's modulus. That's how much it deforms over a certain amount of load. So for right now, just put a 1 in for everything, and that's going to give you like that. We have to go to a load, and on this example problem, I think that there was a load right here at D, pulling down at 500. So what I'm going to do is I'm going to have to go down here to the number 4. So you see number 4, and in the X direction, the force in the X direction was 0. It wasn't pulling left and right, but it was pulling down at 500. So I type in negative 500, and you'll see that there's the force that pops in. If you wanted to put a force at 3, then you would do it here, X and Y. If there was a force at the top, you'd put it here in number 2 on your individual members. Our supports, we had a support, there was one in the X and the Y here at A. So over here on node number 1, there's an X and a Y. So you'll see that it makes a pin. So there's a pin right there. And then over here at number 3, there's a support in the Y, and that's a roller. So we've got a roller here, a support force at C, and then we've got a pin which keeps it from going left and right and up and down over there. So then, once we have everything in, we just kind of worked our way across the top, and then we're going to hit results. So then right here, it's going to tell us exactly how much force is going on. So right now, first of all, our reaction forces. At number 1, there's no left and right. The X means left and right, so there's no force left and right, and there's an upward force of 350. So this is supporting 350. And then this is the Y at 3, so there's an upward force of 150 right there. And this will tell me how much force is going on inside of each member. So in number 1, once it becomes negative, negative means compression. So number 1 is under compression, 440 pounds. Number 2 is also under compression. It's at 300 pounds. Number 3, this is in tension. So this one right, and they kind of color code it. See how it's lighter blue than the other ones is? So number 3 is at 262 pounds. Number 4, also 262. And then the last one, 500 pounds. If we were going to start using like Young's modulus in the cross-sectional area, this would start telling us what's called strain, force divided by area. And then you'd start getting into how far it stretches. So right now, because we put ones in for everything, this is telling us how far this is going to stretch, which don't really mean anything until we put the correct numbers in. So suffice to say, the only numbers we are really concerned about are these numbers right here, and then our reaction forces in the X and then the Y. All right, thanks for watching.